Today we're going to talk about limiting reactant problems. With a limiting reactant problem, we can kind of think about it like a grilled cheese sandwich. If you want to make grilled cheese sandwiches one day after school, and you go home and you have 3 slices of cheese, but you have 2 loaves of bread, and we want to know, what are we going to run out of first, cheese or bread? Or in other words, what's going to limit us on making as many grilled cheese sandwiches as possible? Well, we have fewer slices of cheese than we do with our bread. So when we put the 2 slices of bread together with the 1 slice of cheese, you can keep going until you run out of that cheese, even though we have excess bread. Same thing happens in a chemical reaction. If I have ammonia reacting with oxygen, my 2 products here are the nitrogen monoxide and water. When these 2 combine, they're going to keep combining and keep combining and keep combining until one of these 2 are going to run out. When one of the reactants runs out, the chemical reaction stops. So when we get actual numbers here, like we have 2 grams of ammonia, the NH3, is mixed with 4 grams of oxygen. I want to know what is the limiting reactant, meaning what's going to make the chemical reaction stop first. We're going to do 2 gram to gram problems. With our 2 gram to gram problems, you're going to start one of the problems with the 2 grams of ammonia. You're going to start another problem with 4 grams of oxygen. In order to do a gram to gram problem, we have to balance our reaction just like any other stoic problem that we've done so far this year. So to balance this one out, I actually balanced it off to the side here. We get a 4, 5, 4, 6 to balance it. Now looking at your problem, the first one says that we have 2 grams of ammonia. The other one says that we have 4 grams of oxygen. I want to know what is the limiting reactant, meaning which of the 2 reactants, ammonia or oxygen, will run out first. So in order to do this problem, what we're first going to do is we're going to take grams of ammonia and we're going to figure out how many grams of one of the products you can make. It doesn't specify which one to choose. So because it doesn't specify, choose one and stick with that one for every problem that you do. So you're going to use it for both of these 2. Now we're going to have to find a molar mass of one of these 2 at the very end in order to do the stoic problem. So usually I pick the one that has the easier molar mass. Some people always pick the first one, some people always pick the last one. It doesn't matter, it's totally personal preference. In this problem, offhand, I already know the molar mass of water is 18.02 grams, is the mass of 1 mole. Because I already know the molar mass of water, I'm going to choose that one. If you wanted to choose your nitrogen monoxide, you could have done that too. So we're going to figure out, if we have 2 grams of ammonia, how many grams of water we can make in the end. So we're going to run a normal gram to gram problem, like we've been doing. So I take my grams, turn it into moles. Grams cancels. The next step, I need my mole to mole ratio. Moles of ammonia is going to go on the bottom. Moles of water is going to go on top. For every 4 moles of ammonia, I have 6 moles of water. In the last step, I'm going to take my moles, turn it into grams. 1 mole of water has a molar mass of 18.02 grams. So moles of ammonia is gone, moles of water is gone, leaves me with grams of water. I'm going to set up the second problem, then I'll get out my calculator and do that problem. So again, we have grams, but this time it's of oxygen. Again, I want to know how many grams of water I can make if I start with 4 grams of oxygen. Molar mass of oxygen is 32 grams, is the mass of 1 mole. Mole to mole ratio, 5 moles of oxygen for every 6 moles of water. Then convert my moles to grams. Moles cancels, Grams cancels, leaves me with grams of water. So now I can dig out my calculator. When I dig out my calculator, I'm going to take 2 times 1 times 6 times 18.02 divided by 17.04 times 4. I have 3 sig figs, so I need 3 sig figs in the end. 3.17 grams of water is one answer. I need the second answer. 4 times 1 times 6 times 18.02 divided by 32 times 5, 2.70 grams of water. So now I have 2 answer choices. I need to figure out what is my limiting reactant. The limiting reactant is the one that makes the fewer in the mass for your answers. So we're going to look to see which one is less. This one is 3.17. This one's 2.70. Because we make less with our oxygen, my limiting reactant, LR, it's limiting reactant, is oxygen. Because if we start with 4 grams of oxygen, we can only make 2.70 grams. It's kind of like the grilled cheese sandwiches. If I have 3 slices of cheese but 2 loaves of bread, I can only make 3 sandwiches because that number is less. The second question here says, which is in excess? The one that's in excess, you have more of. So we have excess ammonia. That just means that there's more there that's just waiting for other oxygen to react. So our bread is in excess if we have a couple loaves of bread. Now the other type of question that they're going to ask you, how much can be made? It says what mass of water can be produced, so that's our product, if 4 grams of hydrogen reacts with 16 grams of oxygen. So I have water being produced. Hydrogen and oxygen are my reactants. Got to balance that guy out like this. Same thing, I have 4 grams of hydrogen and I have 16 grams of oxygen. I'm going to set these up and I want to know what mass of water I make in the end on both of them. So first thing, take your grams, turn it into moles. Molar mass is 2.02 grams, is the mass of 1 mole of hydrogen. Then I use my mole to mole ratio. For every 2 moles of hydrogen, I make 2 moles of water. Then I need to take my moles and turn it into grams because it says what mass. 1 mole of water is equal to 18.02 grams of water. So I'll do my math in a second. Same thing on this one, 16 grams of oxygen. We're going to turn our grams into moles. So the molar mass of oxygen is 32 grams. Mole to mole ratio, for every 1 mole of oxygen, I make 2 moles of water. Then I'm going to take my moles and turn it into grams. 1 mole of water is equal to 18.02 grams of water. Moles is done, moles of water, oxygen, grams of oxygen. So on both of them I have grams of water, so I just plug it into my calculator again. I take 4 times 1 times 2 times 18.02 divided by 2.02 times 2. With 1 sig fig, this one is 40. This one we're going to take 16 times 1 times 2 times 18.02 divided by 32. 2 sig figs, we get 18 grams. So with 16 grams of oxygen, I can make 18 grams of water. With 4 grams of hydrogen, I can make 40 grams of water. I want to know what is the maximum mass that I can make. So your answer is the less of the 2 or the fewer of the 2. I'm not quite sure what the terminology is there. You want the smaller number. So we're going to choose 18 grams is the maximum amount that you can make because you're going to run out of oxygen before you run out of hydrogen.